nobody built them. That's the conclusion some people have quietly arrived at. Because if you actually sit down and do the math, the sheer volume of stone, the precision of the angles, the fact that the Great Pyramid was the tallest structure on Earth for nearly 4,000 years, at some point your brain starts to reject the idea that humans with bronze tools and rope pulled this off. And for a long time, we genuinely did not know how, but something has changed. In the last decade, archaeologists haven't just found new clues. They found a diary, written by one of the workers, describing in real time exactly what was happening on that construction site. And what it describes rewrites almost everything you thought you knew. So, let's build a pyramid, from nothing, step by step. And by the end of this, you're going to understand something that has confused historians for 2,000 years. Before we talk about how, we need to understand why, because the reason behind the pyramid changes everything about how it was designed. The ancient Egyptians had a specific, concrete belief about what happened when a pharaoh died. In their understanding, the pharaoh wasn't just a king. He was a living god, the human vessel of Horus, the sky deity, and when he died, he transformed. He became Osiris. He joined the eternal realm. But that transformation required conditions. The body had to be preserved. Exactly. The soul, what they called the Ka, needed a home to return to. And the journey to the afterlife required provisions. Food, servants, treasures, tools. A tomb wasn't a memorial. It was a launch pad. And a pharaoh's power in the afterlife was believed to reflect his power on earth. So if you were the most powerful man in the world, you needed the most powerful tomb ever conceived. Khufu, the pharaoh who commissioned the Great Pyramid around 2560 BC, apparently decided that what came before wasn't enough. His father Sneferu had already built 2 large pyramids. Khufu looked at them and essentially said, "Bigger." The result was 2.3 million stone blocks, a base the size of 10 football fields, a structure so geometrically precise that the 4 sides align with the cardinal directions to within a fraction of a degree. Which raises the obvious question, why a pyramid shape at all? This is the part most documentaries skip over, and it's genuinely fascinating. The pyramid shape wasn't arbitrary, it was cosmological. The Egyptians called the primordial mound that rose from the waters of chaos at the beginning of creation the Ben-Ben. It was a tapered, pointed form, the first solid thing to exist. A pyramid was a permanent stone recreation of that sacred shape. The pharaoh's tomb was literally a monument to the moment the universe began. When the sun hit the polished white limestone casing stones at dawn, and originally these pyramids were blinding white, not the rough sandy colour we see today. The tip would catch the light first, glowing like a captured piece of the sun itself. There's also a structural reason. A pyramid distributes its own enormous weight downward and outward to a broad base. It is, in engineering terms, one of the most stable shapes a large stone structure can take. The Egyptians may not have had the mathematical vocabulary we use today, but they had centuries of empirical knowledge about what stood and what collapsed. They weren't guessing. They were building on everything that had come before. Here's what I want to be straight with you about. There is still no single, universally agreed upon answer. What we have is a convergence of evidence. Physical remains, ancient texts, modern experimental archaeology, and one genuinely remarkable discovery that together paint a picture detailed enough that most Egyptologists are now fairly confident in the broad strokes. The conspiracy theories that blame aliens or lost civilizations exist because for a long time, the mainstream answer, they used ramps and sleds, felt deeply unsatisfying. It didn't explain the precision. It didn't explain the logistics. It felt like a shrug. But the diary changes things. In 2013, archaeologists excavating a cave near the Red Sea port of Wadi al-Jarf found something unprecedented. A papyrus journal written by a man named Mira, who was a mid-level official overseeing a team of workers on the Giza construction sites. It is the oldest known papyrus ever discovered, and it is a logbook. Day by day, journey by journey, it records the movement of limestone from the quarries to the pyramid. What it reveals is a supply chain of almost modern complexity. Step 1. Choosing and preparing the site. The Giza plateau was not chosen by accident. It sits on a thick shelf of solid limestone bedrock, capable of bearing millions of tons without shifting. The site also sits near the Nile's floodplain, giving water-based transport access for heavy materials. Before a single stone was laid, workers leveled the base to near perfect flatness. The entire foundation platform, over 53,000 square meters, has a variance of just 2.1 centimeters from one corner to the other, with no laser levels, using water channels and careful measurement alone. Step 2. Quarrying the stone. Most of the pyramid's core blocks, the rough interior fill, came from a quarry immediately south of the construction site. Workers used copper chisels and wooden mallets to cut channels around each block, then drove wooden wedges into the cracks, soaked them with water, and let the expansion fracture the stone free from the bedrock. The casing stones, the smooth white limestone that originally covered the entire outer surface, came from Tura, across the Nile, about 13 kilometers away. These required a completely different journey. Step 3. Moving the stone. This is where Mera's diary becomes extraordinary. He describes his team loading limestone blocks onto wooden sledges, hauling them to the Nile bank, loading them onto flat-bottomed boats, sailing across to a specially constructed canal near Giza, then moving them by water directly to the building site. Water transport was the key that most early theories missed. Moving a 2-ton block by boat requires a fraction of the human effort needed to drag it over land. The Egyptians built an entire hydraulic infrastructure, canals, harbours, basins, specifically to serve this one construction project. On land, teams of workers pulled the sledges using ropes, with workers pouring water or perhaps a lubricating liquid onto the surface in front of the runners. Ancient wet sledge technology that dramatically reduces friction. Wall paintings from the same era actually show this technique explicitly. Step 4. Organising the workforce. We used to picture slaves. That image is wrong. Archaeological evidence from the workers' village at Giza, found in the 1990s, shows a permanent, organised, well-fed workforce. They ate beef. They received medical care. Excavated skeletons show healed fractures, evidence of surgical procedures. They were divided into named crews, with rosters, supervisors, and ranks. Estimates suggest between 20 and 30,000 workers were active at peak periods, not simultaneously swinging hammers, but organised into rotating teams. Quarry crews, transport crews, placement crews, finishing crews. It operated more like a construction company than a slave gang. Step 5. Raising the stones. This is still the part with the most debate. How did they get the upper blocks some weighing 80 tons, hundreds of feet into the air. The leading theory, supported by structural evidence found at unfinished pyramids, is an internal spiral ramp. A ramp that corkscrewed up through the interior of the pyramid as it was built from the pyramid's own stone, and later sealed off as the outer casing was finished. French architect Jean-Pierre Houdin spent years developing this model, and thermal imaging of the Great Pyramid has revealed density variations in the upper structure consistent with it. Some researchers believe external ramps were also used for the lower levels, where the angle of ascent is less steep, transitioning to the internal ramp system as the structure grew taller. Step 6. Precision finishing. The final casing stones were fitted to tolerances measured in millimeters. Ancient Greek historian Herodotus noted that in his time, 2,000 years after construction, you still could not slide a blade between the joints. The capstone, a single pyramidion, possibly sheathed in gold, was placed last. Then finishing crews worked downward from the top, cutting the casing stones to their final smooth face as they descended. By the time they reached the base, the surface was complete. Here's the thing that stays with me about all of this. The Great Pyramid was completed around 2560 BC. For the next 3,800 years, it was the tallest structure ever built by human beings. Nothing surpassed it until the Lincoln Cathedral in England was finished in 1311 AD. The people who built it didn't have the wheel applied to transport. They didn't have iron tools. They had no written engineering manuals, no architectural software, no cranes running on electricity. What they had was organization, precision, a system of knowledge passed between generations of craftsmen who refined their technique across 3 dynasties, until they arrived at something the world would not see again for 4 millennia. So have we finally figured out how they built the pyramids? Mostly, yes. And honestly, the real answer is more impressive than any alternative. Because it turns out the most extraordinary thing about the pyramids isn't that they defy explanation. It's that human beings, with nothing but time, intelligence, and an almost incomprehensible degree of collective effort, actually pulled it off.